All right, so in this video, I'm going to talk about example 12 on our notes on asymptotes. Now, a couple things to point out to you is this is our first type of function where we have both a rational function, a fraction, and a square root in the same problem. And this is going to be important to point out for a couple of reasons. Now, let's go back to what we were talking about before where we look for vertical asymptotes, because most people really are pretty good at finding those. So when we do vertical asymptotes, what we're looking for are discontinuities. We're looking for where the denominator equals 0. So I'm going to take that denominator, x squared plus 4 under the square root. I'm going to set it equal to 0. And what I'm going to try to do is I'm going to try to solve this. Now, in order to get rid of the square root, we're going to square both sides. So I'm going to square everything. Okay. And so we're going to have x squared plus 4 left over. And 0 squared is 0. Now I'm going to subtract 4 from both sides. And I get x squared equals negative 4. And if I try to square root it, we're going to have to do the square root of negative 4, which is, imaginary. Which means, in this situation, there's no real number that's going to give me 0 in the denominator. So I know there's not going to be any discontinuities, which means no vertical asymptotes. Okay. Again, kind of an interesting case here where we have a rational function, a fraction, that doesn't actually have anything wrong with it. It has no discontinuities. It has no vertical asymptotes. It doesn't even have a hole in it. It's perfectly continuous everywhere. Now, based off of this, I want to keep going and start talking about some of the other stuff. Now, a point of confusion that some people have with this is that they look at this and see the x squared in the bottom and say this is bottom heavy. Where I would really like to agree with them, but unfortunately that is not the case. And the reason that is, and I want to point this out, is because notice this is an x squared under a square root. So I'm thinking about it from this perspective. If I have the square root of x squared, that's actually just going to be x to the first. So really that's got a degree of 1, and that's got a degree of 1. So this is not top heavy, nor is it bottom heavy. This is one of those situations where essentially the degrees are the same. Now, I am going to point one other thing out, and I know I've mentioned this before. Think about when you square something. If you have a positive number and you square it, you get a positive number. But if you have a negative number and you square it, you still get a positive number. So what's actually happening here is when you square root this, you're actually going to have a plus or minus x, or you can think about it as an absolute value of x. So one of the things that I want to think about here is if I try to use that shortcut I shared on example 10, where I take the leading coefficients of each and I divide them. In this case, I'm going to take 1 over essentially the square root of 1. I'm not going to get the only answer. I've got to include that plus or minus. So this is actually a positive 1 and a negative 1. This is a wonderful example of a function that actually has two different horizontal asymptotes. It's got one at y equals positive 1 and one at y equals negative 1. Now, in reality, do I expect every student right off the bat to have this idea under their belt and say, yeah, I can figure out when there's two horizontal asymptotes? That's easy. Probably not. But here's the thing. If you're not 100% sure about these asymptotes, check them. So what I mean by that is this. What I'm going to do is I'm actually going to go through and I'm going to find the limit as x goes to positive infinity. And then I'm going to go through it. I'm going to check the limit as x goes to negative infinity. And if I do both of these, and like I said, it's honestly, if you do it numerically, that's fine. It'll probably help if you do it numerically. That way, it's a little bit easier. You could even graph it and try to see what's happening there. I'm just going to do it numerically because it's not going to take me very long. Let's try, I don't know, let's see. I'm going to try the number 50. I'm going to try the number 100, and let me try 500. And that's going to go positive infinity. Let's try negative 50, negative 100, and negative 500. And I just want to see what's going to happen. So if I type these in my calculator, let me do that. 50 minus 1 over the square root of 50 squared plus 4, I get 0.979 and some extra stuff. If I do 100, let's see what happens. If I do 100, I get 0.9898 and a bunch of stuff after that. And if I try 500, we get 0.997992, and a bunch of stuff after that. So like I said, as these x's head toward positive infinity, if I check these y values, they're headed toward positive 1. But let's go ahead and check these negatives too while I'm at it. So let me do negative 50 first. If I try negative 50, let's see, I get negative 1.019 and a bunch of stuff after that. Let me try negative 100. I am rounding these correctly, by the way, just to make sure I get my point across. The next one I get is negative 1.0098. And let's try 500. Excuse me, negative 500. At negative 500, we get negative 1.00. I'll just round it off at 2. So that appears as x goes to negative infinity that the y values are headed toward negative 1. Again, this is a great justification for why I have two different horizontal asymptotes. This one goes to negative 1. This one goes to positive 1. So there's two horizontal asymptotes, but no vertical asymptotes on this particular problem. So hopefully this helps. Again, if you have any questions, feel free to ask me. Hopefully you guys have a